Hello friends, today in this session we will understand surrogate safety measures at highways and intersections. Surrogate safety measure is one of the most widely used methods nowadays for identifying potential collision either on a highway or intersection. And it is because road safety has become a global problem and accidents records available with police are not always sufficient or reliable. These road crashes are recognized as a global problem, and in India also it is a serious issue. India is losing 3% of its GDP because of road crashes. 365 people died each day in 2020 in road crashes in India. That means by the time you complete this video, 5% will lose their life somewhere on roads in India. India has 2% of global vehicular volume, but it contributes to almost 11% of the global road fatalities. India ranks number 1 in the world in terms of fatalities on roads. And safety of facility can be defined as the number of crashes by type expected to occur at a facility in a certain period per unit time. Now, the definition of a road crash as given in IRC 53 is that this is an accident, either collision, overturning or slipping, which occurs or originates on a road open to public traffic, resulting in either injury or loss of life or damage to property in which at least one moving vehicle was involved. And major objective of all research studies on safety of various traffic facilities, including facilities that have not yet been built, has been to establish correlation between the number of crashes or crash rate to the operational variables. And the operational variables which are considered are annual average daily traffic, average speed, posted speed limit, and geometric parameters which are of interest are lane width, shoulder type, shoulder width, gradient, curvature, and side distance. Now, there are several limitations of official accident database, and many reports have indicated that official number of accidents are highly underreported. Road accidents usually reported and recorded for fatality or major injuries, and they are not followed at hospital level. Road collision resulting from only in damage to the vehicle are settled from vehicle insurance companies and majorly not reported. There is a least or no coordination between the officials and various vehicle insurance agencies for reporting and recording road accident data in India. And proper collision cause data, that is casual analysis of reported accident, is not robustly available. And safety analysis can be either using the data from observed crashes or it can be based on conflict. Now, it is because crashes are rare and random, and countermeasures can only be taken after occurrence of a crash. And if you take any action before occurrence of a crash as per crash-based analysis, it will be not accepted by the government, or you can say it will be ethically unbiased to the countermeasures until the collision has occurred. Whereas conflicts occur more frequently, and this conflict is an observable situation in which two or more road users approach each other in space and time for such an extent that there is a risk of collision if their movements remain unchanged. Now, conflict point represents a fixed location in space where crossing flow intersects with straight through flow at intersection or in merging areas. And a conflict shall turn into a crash when all the unfortunate parameters and conditions are fulfilled. In other words, before the collision, there exists a point where the follower can take action to avoid collision. And the collision can also be avoided after the set point but the measures and actions required will be very drastic or uncomfortable. Many studies have indicated that if you provide 1 or 2 extra seconds to the driver, then he or she can avoid the accident. Now, this is the line which is called the border between serious and non-serious conflict. Now, if you see at a speed of 50 km/h, the border line is 2 seconds, time to accident. So, if the driver is warned before 2 seconds of an accident, there are chances that serious conflict can be avoided. But if he can be given more than 2 seconds, then it will certainly be a non-serious conflict. Similarly, at a speed of 75 km/h, this point here is at 3 seconds. So if a driver can be warned more than 3 seconds before the accident, then a serious conflict can be avoided. Now, this is a condition on a highway. 2 vehicles are moving in the same lane. This is the leader and is the follower. So, if follower is moving at a speed faster than the leader, then collision is bound to occur if the follower does not decelerate or it does not stop. Similarly, at an intersection, if there are 2 conflicting streams, then this is the point of conflict here, and this is called the angular collision. When the same location is shared by 2 vehicles arriving from different roads at the same time, and if this vehicle or this vehicle does not take any action, then conflict will occur at this point. Now, let us take a case on a highway where 2 cars are moving in the same direction. This is the leader and is the follower. And if you plot simultaneously when they move, time distance diagram of these 2 cars, leader and follower, then it will be like this. When 2 cars are traveling the same speed, these 2 lines will be parallel. And this is the time headway between the car, this is the space headway between 2 cars, and will remain constant throughout the time. But when the speed of the follower is more than the speed of the leader, then these 2 lines will merge, and that will create a condition of conflict or crash. Say again the same situation. You have 2 cars. The leader is following a speed, but the follower is moving at a speed faster than the leader. Then at this situation, if they continue the same speed, they do not take any action, the conflict will occur at this point. But if the follower vehicle takes some decision, then this conflict can be avoided. Now, this vehicle has decelerated here, and therefore after deceleration, it will reduce the speed and the conflict can be avoided. You can see here the conflict point is nullified due to follower's decision to decelerate. Now let us consider a situation where a vehicle is turning right from a minor street and a vehicle is already on the major street going straight. So this is the leading vehicle here, turning vehicle is taken as the leading vehicle, and the through vehicle is taken as the follower. Now this is the conflict line example. Now at time t1, the leading vehicle enters the encroachment area. That is, it starts to turn right into the same lane as the follower. And at time t2, this vehicle which is on the main street, it realizes that a collision might occur, and therefore it starts braking to avoid the collision. And it continues deceleration up to this point, that is t5. So if this vehicle continues at a normal speed, it doesn't decelerate, then this will be the time when it will reach to the encroachment point, that is t5. But if it stops decelerating at this point and then you project this line further, then T7 will be the time when it reaches this encroachment point. But if it continues decelerating and then it goes up to here and then it starts at the normal speed, then this is the time T9 when it will reach the maximum reference distance. Now, maximum reference distance is required to calculate surrogate safety measure. Now, similarly, if you take another example, when there is a right turning vehicle from the major street and a through vehicle on the major street. So this vehicle is going right, that is a leader, and is the follower. So this is the timeline of a rear end conflict line for a vehicle turning off of the main street onto a minor street in front of a vehicle which is going straight through the intersection. Now here also you can have time T1 to T8, and these can be explained like this, that at time T1 the leading vehicle is a turning vehicle. Leading vehicle start decelerating to turn off of the main street because it requires to reduce the speed to take a turn, and therefore it is the time when it starts decelerating. And at time T2, the following vehicle realizes that a collision might occur, and therefore this vehicle also starts decelerating or braking to avoid the collision. Now, this is the trajectory of the vehicle if it doesn't decelerate. That is time it will reach to zero position at this time. And after decelerating a little, if it stops decelerating and then continue that at this speed, then this T5 will be the time when the follower will reach to this point. And if this decision continues up to this point T6, then it will reach to this distance of leader at road exit will be T8 at time T8. Now the major challenges to traffic conflict are that there is still some debate regarding the connection between conflict measures and crash prediction. But there is a consensus that higher rates of traffic conflicts can indicate lower levels of safety for a particular facility. And conflicts generally result from a lack or misunderstanding of communication between the different road users. So the essence of proactive safety assessment is that from the observed traffic events of different nature, if conflicts are prevented from happening or mitigated in number, then crashes can also be prevented or at least reduced in numbers significantly. So that is the philosophy of proactive safety assessment, or you can say analysis through surrogate safety measures. Let us now discuss surrogate safety measures. Now, safety analysis based on conflicts provide better insight into the cause and effect related to the collision. Therefore, interest over time developed in obtaining surrogate measures that are correlated with or predictive of crashes. The word surrogate means substitute or replacement, and therefore by using surrogate measures to determine traffic safety, we mean to substitute the need for crash data with another factor which would represent traffic safety. And the surrogate measures developed are on the basis of identification, classification, and evaluation of traffic conflict. The surrogate safety measures are representative parameters estimated based on the vehicle's movement following their trajectory, that is speed and direction. In general, surrogate safety measures are divided into two major groups, temporal and non-temporal. The non-temporal measures are also subdivided into three categories based on measuring attributes such as distance, acceleration, and indicators based on temporal proximity are the most popular measures because they integrate both the spatial proximity and speed. The different safety surrogate measures that have been used in literature are like this: gap time. Now, this is the time lapse between completion of encroachment by turning vehicle and the arrival time of crossing vehicle if they continue with the same speed and path. Now, this gap time is similar to time to collision. There is also expected time for two vehicles to collide if they remain at their present speed and on the same path. Another one is encroachment time. Time duration during which the turning vehicle infringes upon the right of way of through vehicle. Now, this is replaced by post-encroachment time more conveniently. And that is the time difference between the leading and trailing vehicle to occupy same longitudinal position. So this definition is more general than this one. This is mainly on intersections. And the deceleration rate at which crossing vehicle must decelerate to avoid collision. Or you can say rate at which a following vehicle must decelerate to avoid a collision. Now, two important parameters which are very commonly used, that is time to collision and post-encroachment time. Now, this time to collision, the time that remains until a collision between two vehicles would have occurred if the collision course and speed difference are maintained. That means no action is taken by both vehicles. And the minimum TTC observed during an interaction is considered as an indicator value. So, TTC is delta x upon delta v. Delta x is the space difference in space, and that is the difference in speed of two vehicles. For speed of following vehicle being larger than speed of leading vehicle. Otherwise, it becomes infinite. And similarly, the time difference between the leading and trailing vehicle to occupy same control position is PET, that is post-encroachment time, and this is the difference in time of two vehicles crossing the same point on the highway or in the intersection. If you take the same example which we take earlier, when two cars are moving on a highway and there is a leader, there is a follower. Now, if the two vehicles move at their normal speed without taking any action, then there is a possibility of collision at this point. So, this is the time to collision of the leading vehicle, and this is the time to collision point of the following vehicle. So, in case of rear end conflict, time to collision will be delta x, that is the difference between their distance, or that is distance between two cars, and their relative speed, delta v. But in case of angular conflict, maybe at intersection or when two streams merge together, then time to collision will be maximum of these two values. Time to collision of a following vehicle and time to collision of the leading vehicle. So, TTCPL will be given by speed upon distance for leading vehicle, and for following vehicle it is for, and TTCPF will be VF upon XF. Now, this vehicle interaction will result in a conflict when TTC is less than a specified threshold value, and generally it is taken as 2 seconds. But lower the value of TTC, more critical and riskier will be the conflict. Similarly, if you take on a highway that this is the point, common point shared by leader and follower, and then you observe their movement, they are moving at constant speed, then in that case, this is the time to collision for leading vehicle, and this is the time to collision point of the following vehicle. So, this is called the post-encroachment time. That is T, time to collision of following vehicle minus time to collision of leading vehicle. That is post-encroachment time. So, vehicle interaction will be conflict when PET is less than a specified threshold value, and this value is taken as 1 second or sometimes 2 seconds. When you have merging conflict, a colliding vehicle, a vehicle coming from the side road merges with the traffic stream on the major expressway. When same location is shared by two vehicles arriving from different roads at the same time, then it is called angular collision. For example, this is the point of collision here. For angular conflict, this condition that VF should be larger than VL is not necessary. It occurs when same space is shared by two vehicles with really very less time difference. And that time difference is called TTC. Maximum of time of arrival of the following vehicle and leader vehicle. So PET will be difference between these two. Now surrogate safety measure on conflict point diagram. Now this is the conflict point diagram at an intersection where you have a through vehicle and a crossing vehicle. Now here also time T1 is the crossing vehicle enters the encroachment area. At time T2, this vehicle realizes that a collision might occur and therefore it begins braking to avoid collision. At time T3, the corner of the rear bumper, that is either right or left rear corner, depending upon travel direction of the crossing vehicle, leaves the encroachment area. Time T4 is when the through vehicle is projected to arrive at the conflict point if it continued at the same speed. And this is the T5, the actual arrival at conflict point. So here, this is the post-encroachment time. From this time to this time is post-encroachment time. This is the time after taking action by the through vehicle. But if it doesn't take any action, then this is the time to collision, TTC. So these are two important parameters which you can determine from trajectory of vehicles. How this conflict can be determined from either field data or from simulation data. You see these two-wheelers here, they are moving in their direction at, let us say, at this point of time A. At point B, they are now closer, but still they are moving in the same direction. And if they continue in the same direction, with the same speed, they will collide. So what happens that this has to take some action to avoid the collision. So this driver has changed its path, and that is how the collision is avoided. That is the now new path or new trajectory of this vehicle so that it does not collide with this vehicle. So that is how you determine the collision, time to collision or post-encroachment time from field data or from simulated data. And there are several benefits of surrogate safety measures based safety assessment. And the first is that the absence of crash data for new designs of road facilities and novel technologies such as connected vehicle means crash-based safety assessments cannot be carried out in such cases. SSM helps in overcoming this hurdle. And this is a robust identification analysis of safety hotspots, evaluation of safety treatments, and ranking of traffic infrastructures based on safety standards. Even for vulnerable road users, evaluation of different safety-based policies is possible through surrogate safety measures. Effect of behavioral changes of a driver or in the driving environment on the safety aspect can be evaluated. Utilizing vehicle-to-vehicle and vehicle-to-infrastructure level communication for conflicts or collision avoidance applications can also be possible, and it is suitable for studying the crash mechanism and gaining deeper insights in evolution of vehicular interaction into conflict or crash and severity involved in vehicular interaction. So friends, thank you very much for watching this video. You can write your comments in the comment box.